Hello and welcome to this module on denial of service. Let's see what we'll be covering. We'll kick off with what is denial of service. Then we'll follow that with what are the goals of denial of service. In other words, why do attackers actually attack targets with a denial of service attack? Then we'll move on to the different techniques that attackers use to create a denial of service. And then finally, we'll close off with what are the countermeasures against denial of service. Let's get started. So, what is denial of service? Well, let's take a look at the definition. So it says here, a denial of service is the interruption, very important, in an authorized user's access, also important, to a computer network, typically one caused with malicious intent. Okay, so in very plain and simple English, that basically means that it is literally what it says. It's a denial of service. So, for example, you have a website and a denial of service attack will take that website offline so that authorized users, in other words, normal users of the actual website, cannot get service from that website, and it's usually caused with malicious intent. In other words, there's a bad actor in the background who's actually causing this server to be or service to be offline. So that in a nutshell is a denial of service. And then let's move on to a distributed denial of service. And a distributed denial of service is an attack which occurs when multiple systems, important, multiple, hence the term distributed. So in a distributed denial of service attack, you have not one attacker or one machine rather attacking a single site. You have multiple systems, and this is a very common attack these days, to the extent that people are even using Internet of Things devices. So there was a botnet created just the other day which used pretty much CCTV cameras, routers, switches, basically anything that has an IP address, and created one of the largest distributed denial of service attacks out there. So a distributed denial of service and a denial of service end up with the same thing. Something will go offline. The only difference is a denial of service is generally a single actor or a single service attacking another service, whereas a distributed denial of service is multiple attackers. And this one is very, very difficult to stop because you cannot filter all those different IPs that are attacking. But we'll talk about that in the countermeasures. Let's move on. So what are the goals of a denial of service attack? Well, the first thing is to reduce the availability of a service. In other words, make a service as slow as possible so that people don't use it. You could also look at restricting availability to a service. And this is very seldomly done, but there are certain instances where different parts of the world have been restricted from accessing a certain service by a denial of service attack. So, for example, if the service is in country A, people in country B cannot access that service because of a denial of service attack specifically targeting IPs of that other country. Then prevent, and this is probably the main reason that people do denial of service attack, it's to prevent normal use of a service or system. If you take a website offline, nobody can use it. If you take a service offline, nobody can use it. So you're preventing normal use of a service, and it talks to the availability of systems. And then finally, flood. So a flood is basically when you overwhelm the system resources. So you create thousands upon thousands of connections to a specific server, and the server is so busy trying to respond to your flood of requests that it cannot actually respond to the normal requests that it gets on a day-to-day basis. And we'll see an example of that in the demo coming up later. So what are the impacts of a denial of service attack? Well, the impacts can be very, very severe, and that is why there is so much publicity about denial of service in the media. First of all, reputational harm. If your website goes offline, if you're an e-commerce website and you go offline, you're going to lose customers and it's going to ruin your brand. So reputational harm is one of the big impacts. Then, totally disabled networks. If you take an entire network offline because of a denial of service attack, then guess what? Nobody can use that network or any services hosted on that network. You could also disable the organization. A very good example here is account lockouts. If you have a list of usernames for an entire organization, and you know that those usernames are used to access webmail on the internet, you know that they have an account lockout policy where people have to call IT to unlock their accounts, you could write a script that could literally disable the entire organization. So everyone comes to work Monday morning and no one can log in because all their accounts have been locked out. That is an example of a disabled organization via a denial of service. And then finally, financial loss and extortion. And this is actually a very, very big one. And this is probably the main one. So let's take, for example, Amazon.com. Okay, at last statistic that I heard, Amazon.com probably makes about 83,000 US dollars a minute. So could you imagine what a 3 or 4 hour denial of service attack against Amazon.com would cost? And what bad actors out there are doing is they will start a denial of service attack against an e-commerce company and then stop it, and then literally extort or blackmail them and say, listen, if you want your service to stay online, you must pay us X number of dollars or euro or whatever the case may be. So those are the primary impacts of denial of service, and it is a very, very serious attack. Let's move on. Let's look at the different denial of service techniques. First of all, there's the bandwidth flood. This one isn't as effective as it was a couple of years ago because of the enormous amount of bandwidth increases that have been prevalent in the industry. So a bandwidth flood, for example, if you only have 1 meg of bandwidth allocated to a specific server, you could literally use all that bandwidth using a ping request as an example, with specially crafted packets to soak up all the bandwidth so that any other person trying to access that web server or that website would not be able to do so. Then there's the SYN flood. The SYN flood is actually a very interesting technique. So it takes advantage of the TCP IP handshake. And what a SYN flood does is it opens up a SYN connection but doesn't complete the connection. So the web server is waiting for the connection to complete, and by opening up thousands of these connections, it's literally just taking up the server's resources, as the server's not going to close those connections until it gets the ACK request coming back. So the SYN flood actually takes up all the TCP IP resources of a server, and we'll see an example of that in the demo. There's the ICMP flood, which I covered slightly in the bandwidth, and that's by crafting special packets in your ICMP ping request. So as an example, your ping request, you can set the amount of, or the size of each packet in kilobytes to a maximum of 65,535. So if you can imagine 3,000-4,000 of machines all sending a ping request to a specific server using that amount of bandwidth, that would cause a denial of service attack. Then there's the UDP flood, which is similar to the ICMP flood, but it's just using UDP packets. And then what's happening in the industry right now is what's called reflected or amplification attacks. And what that is basically a whole bunch of different computers spoof the IP address of the victim. So, and then they request DNS or NTP traffic from a DNS or NTP server. The DNS or NTP server then responds with thousands of these requests back to the victim, not to the attackers, because the attackers have spoofed the IP address. And this is what's called a reflected or amplification attack. And then finally, there's also account lockouts, which I covered earlier, where you write a script and lock out accounts for an entire organization. And then finally, physical sabotage. So a very good form of denial of service attack is if you break into an organization and steal their server, guess what? They will not have any servers or services running. So that is in effect a denial of service attack. Okay, let's move on and look at the countermeasures. So the countermeasures here that we're going to describe work very effectively against denial of service. There are some countermeasures against distributed denial of service, but but trying to block a distributed denial of service attack is a lot more difficult than a simple denial of service attack. Let's take a look. The first one is you can decide to just absorb the attack. Maybe you've got enough bandwidth, maybe you can allocate more bandwidth, maybe your ISP can allocate more bandwidth, and you can absorb the attack. Not a very effective countermeasure, because as the attacker increases their attack, you will need to increase your resources to absorb the attack, and there will come a point when you won't be able to absorb it any longer. You could also just live with a degraded service, also not really an option, so not really a countermeasure either, but that is what a lot of organizations are forced to do. And you literally just have the degraded service until the denial of service attack has ended. You could look at literally going offline. Also not a very good countermeasure, but it has happened in the past where organizations have chosen to just go offline, put up a page saying that they cannot render any services because they are under attack. You could also deflect the attack, and this is where you need the assistance of your network engineers and your ISP engineers. And what a deflected attack or a deflection of the attack does is it takes the attacking IPs and deflects them to a black hole somewhere so that they don't actually end up hitting the server that is under attack. So this takes a lot of work, and it's a lot easier to do with a simple denial of service. Distributed denial of service, especially if people are spoofing their IPs and changing them all the time, this proves to be very, very difficult indeed to actually do in the real world. You could look at filtering, which is similar to deflecting, but all filtering does is it actually blocks those IPs entirely, so it doesn't accept any connections from attacking IPs, but it has the same limitations that the deflect countermeasure has. There are hardware devices out there that do deflecting and filtering for you automatically, and if you look at the major hardware vendors, specifically the ones who create firewall appliances or UTM appliances, people like Cisco and Fortinet and Palo Alto, they all have denial of service mitigation built into those devices. And probably the one that works the best is third-party services. So there are third-party services out there that actually offer denial of service protection. And what they do is they've got massive networks and massive amounts of bandwidth. And they also have threat intelligence, so they actually can identify malicious IPs. And what happens is you filter all the traffic that's coming to your site through these third-party services, and they will then either absorb or deflect or filter those for you so that only clean traffic comes to your website. Good examples out there that provide these services is Cloudflare for your web services and Sucuri. Okay, and that pretty much ends this theoretical video on denial of service. Thank you for watching.